Okay, now we're going to go over the traditional way of how vaccines are made. So I say traditional just because I want to clarify that there are newer, more modern ways of making vaccines, but in this episode we're just going to go over really the traditional steps to making a vaccine, which I think is the best place for you guys to start to learn the different steps to the process. So 4 major blocks of steps here. So first we've got to actually make the antigen. So that typically involves the traditional way of, we usually make the entire pathogen itself. So we usually make influenza virus, for example, or measles virus, or for the DTaP vaccine we'd make tetanus, for example. And not only would we want to make tetanus, but we want to make the toxin that tetanus produces. If you remember, the DTaP vaccine is actually a toxoid vaccine. It's not against the bacterium themselves. Okay, so step number 2 is that once you make that pathogen, then you want to transform it into a kind of pathogen that isn't going to cause disease or make you contagious. So in the traditional sense, there are 2 major ways of doing that. There's inactivation of the pathogen, and there's attenuation of the pathogen. So 2 very separate ideas and concepts. So if we talk first about inactivation of a pathogen, an example of this would be the influenza virus vaccine, so the flu shot. So typically we take a real flu virus and then we put it through a process to inactivate it. In the lay public, we call this killing the virus. And why do we call it a killed virus? Is because the process keeps intact the outer shell of the virus, but it destroys that genetic material on the inside. So we have all the PAMPs and antigens that we need to make an immune response, but the virus itself is not able to replicate, propagate itself, which means that you're not going to get sick with the flu and you can't pass it on to others. We're going to go into this process in more detail, but I just want you to note that typically with the flu shot, the way that influenza virus is inactivated is with treating it with a chemical called formaldehyde. And it's really important to know that this happens during the process of making that pathogen, but then the formaldehyde is washed away before we get to the final vaccine product. A second example of inactivated vaccine is with the DTaP vaccine. So that's diphtheria, tetanus, and pertussis. And so here, for example, I put the tetanus toxin down. That's the live form of the toxin. We again do a certain treatment to inactivate that toxin. And in this case, for tetanus toxin, we heat inactivate the toxin. So we don't use formaldehyde for this one. We just treat it with heat, and that essentially destroys the toxin so that it can't, cause disease, propagate the illness. But you do have, it's still a PAMP, it's still an antigen, all of those things remain intact. So with inactivation of pathogens, really important to remember that they can't cause disease because they've been quote-unquote killed. So they can't replicate, they can't propagate, but it leaves the outside PAMPs and antigens intact. So if you get an inactivated vaccine, there is no possible way that you can get sick with that pathogen. There's just no way. So that's one major line of misinformation about inactivated vaccines. So the other traditional way of making the vaccine pathogen is via attenuation. So when you hear the words, we're going to weaken the virus or we're going to weaken the pathogen, people are actually referring to this second way of making the vaccine pathogen, which is by attenuation. So remember, to attenuate means to weaken. So that's where we get those words. So the measles virus vaccine is an attenuated vaccine. So we're going to go through this in more detail, so don't worry about all the vocab that I'm going to mention, but just know that we take the wild type or the natural measles virus, we do a series of steps to attenuate or weaken that virus. And so in the end, Even though this virus isn't a killed virus, it's a weakened virus, it can still replicate, but it replicates to such a low amount that it doesn't cause you to be sick, and more importantly, you're not contagious. So we're going to put in just a small amount of virus to activate your immune response, but it's not going to make you sick and you're not going to be contagious. So again, the two major processes of making a pathogen, a vaccine pathogen, are via inactivation or killing and attenuation or weakening. And we're going to go into these in much detail, so don't worry if you don't quite get all the details yet. Okay, so that was our second step. Our third step is to isolate the antigen. So remember, we went through all these steps to produce the pathogen and to inactivate or attenuate the pathogen. We want to get rid of all of those ingredients, all of those reagents that we use to make that. And so we say we're going to isolate that pathogen, isolate the antigen, and we're going to do a number of steps to wash those things away. We're going to go into detail about this. So then once we wash away all of those vaccine production, the pathogen production ingredients, then we're going to assemble our vaccine, our final vaccine product. And so we went into another episode about what's in that final vaccine product, so make sure you check that out. And remember that we're only going to have trace amounts of all the ingredients that went into these stages. So that means that it's going to be less than 1 parts per million, less than 1 parts per billion. One piece of concern that people have is, for example, for the formaldehyde in the flu shot. So on the package insert, you see a list of ingredients and you see formaldehyde on there. And people are nervous because they're like, oh, formaldehyde, that's how we preserve frogs. That's really toxic. But what they don't realize is that has been washed away, and it's really, we call it trace amounts, but it's barely even detectable, if it's even detectable, in that final vaccine product. So really important stuff to remember. So these were the major steps. We're going to make the antigen or pathogen. We're going to make a vaccine pathogen by either inactivation or attenuation traditionally. Then we're going to isolate that pathogen and wash away those previously used ingredients, and then we'll assemble the final vaccine product. So next we're going to go into more detail about the inactivation and the attenuation process.